Okay, so in number one, the first thing I'm going to do is move things around so they all have positive exponents. The 2 is just a regular 2, so it stays where it's at. The x has a -1 exponent, so I'm going to move it to the bottom and make it positive. The y has a negative exponent on top or on the bottom, so I'm going to move it to the top and it makes its exponent negative. Probably the important thing you've really got to keep in mind, the exponent is connected to the base. You cannot separate them. So when you move the y, the 2 moves with it, the 2 just becomes positive. Now that all exponents are positive, I notice there are no bases that are the same. Final answer. Number 2. First, I'm going to move this to the bottom, making it positive. I know that anything to the 0 power is 1, so when you multiply by 1, nothing else changes. Now I'm going to combine all my bases that are the same. The 3 is my only coefficient, so I'm just going to bring it down, keeping it in the numerator. Now, the a's are being divided. When you divide bases, you subtract the exponent, and there's one more a in the top, so that's where my leftover a to the first goes. My x's are all on the bottom. The x's are being multiplied, so I'm going to add the exponents. Don't forget to add, this is x to the first times x to the second, so I have x to the third left. In number 3, the 2 to the -1 goes to the bottom, and this whole thing is to the 0 power, so it's just 1. 1/2. Okay, multiple ways to do number 4. Probably the first thing I would notice, the entire numerator has a negative exponent. I'm going to move the entire thing just like it's written to the bottom, making the exponent on the outside positive. The u to the -2 on the bottom moves to the top and becomes positive. Same with the v to the -2 moves to the top and becomes positive. All right, now I need to simplify my parentheses. So I'm just going to leave my numerator the same. Then I'm going to raise each base. This is a power of a product. So I'm going to raise each base to the outside exponent. And then I'm going to simplify. I'm taking a lot of steps. You might not need this many steps. -2 squared is a +4. Negative times negative is positive. Then I've got power to a power. So I'm going to multiply. Then I've gotten rid of all of my negative exponents, all of my parentheses. Now I just need to combine my bases together that are the same. So I need to put all of my u's together. Since I'm dividing the u's, I'm going to subtract the exponents. There's 2 more in the bottom. So I have a u squared left in the bottom, and the v squared just stays where it's at. So your final answer should have no negative exponents, and all bases that are the same should be combined together. Number 5 can be done many different ways. First of all, you could move the inside b to the top and make it a positive. Then the outside, so I only dealt with the inside on this first step. Then the whole outside is negative, so I'm going to move the whole thing to the bottom, and it becomes positive. And anything to the first power, I don't even need parentheses. What we could have done, because it's a fraction to a negative, is I can flip the inside fraction and make it a positive exponent. And then I can move the b to the bottom to be with the A, notice the same answer. So whichever way makes the most sense to you. All right, number 6, if you just had 8 divided by -2, you know that this would be -4. You deal with your coefficients like you've always dealt with numbers. So 8 divided by -2 is -4. I'm going to leave the p squared in the top. I'm going to move the q to the bottom, making it positive. I'm going to move this q to the top, making it positive. I'm going to leave the r to the 5th on the bottom because it's already positive. Then the only thing I need to combine are my q's. I leave the -4 because that's just a regular number. I leave the p squared. There's more q's in the top. There's one more q in the top. And I leave r to the 5th in the bottom. This is the easiest problem in the entire page. The whole thing has the 0 exponent, so the whole thing is 1. Okay, couple of ways to do this. This has multiple negative exponents. If you want to move the inside one to the top first, that's fine. So the only thing I did here was move my inside negative exponent. Now I'm going to give each one its own -2 exponent. Then these two are going to just trade places. The A goes to the top and becomes positive. The B goes to the bottom and becomes positive. What we could have done at this level up here, because the fraction has a negative exponent, flip the fraction and make it a positive exponent. And we could have just done that. All right, number 9 is kind of different. First, I always need to distribute any parentheses that we need to simplify first. So I'm just going to bring this down. Oh, I'm going to put my y to the -6 in the bottom, plus power of a product. So I'm just going to do power, give each one its own outside exponent. So -1 times -2 is +2. Then y to the 3rd. Really, we're raising each one. Would it help if I wrote it this way? Each one gets its own -2 exponent. So this becomes power to a power. We multiply to get negative or a +2. Power to a power here, you get y to the -6. Now, I want you to think of it this way. This is 3x squared over y to the 6th plus 1x squared, moving the y to the bottom, over y to the 6th. Notice how these are like terms. When you add, you can only add like terms. If I have 3 plus 1, I have 4 of my like terms. And if you wanted to write it as 4x squared, this is the same thing. This way, it's just pulling the 4 out, separating the like term on its own. But it doesn't matter. These are both the same thing. Okay, so I have 2 bases. This is a power of a product. So I can just distribute, multiplying each exponent. Because technically it's saying a to the -1 raised to the -3rd, z squared to the -3rd. So this is power to a power, we multiply. Power to a power, multiply. The a has a positive exponent, so I leave it. The z has a negative exponent, so I move it to the bottom. All right. Different ways to do this one. This 2y, there's nothing I can do with it. I need to distribute my -2 through. The other thing we could do, we could move the whole thing to the bottom and make that exponent positive. So I just move the whole thing down and I just change the outside exponent to a positive. Now let's simplify the bottom, giving each base its own square. So 2 squared is 4. X to the -1 squared is x to the -2. Then y squared. Now I only have one negative exponent to move. So I'm going to move x to the -2 to the top. Now if we just look at 2 over 4, I can reduce it to 1/2. I have y's that I need to combine. I'm dividing my y's, so I subtract the exponent, and the x squared is all on its lonesome, so that's my final answer. All right, I'm going to do similar things to number 12. 4p squared. There's nothing to do with it, so I'm just going to leave it alone. I'm going to move this whole thing to the denominator, and that's just to the +1. As soon as I move it down, the outside exponent becomes positive. Now, truly, if it's to the first power, I don't even need parentheses. Anything to the first power is just the same thing. Now we have 4 divided by 2, so that's just 2. I'm dividing both of these by 2. Technically, it would be 2 over 1. P squareds cancel, and the q is left on the bottom. You don't need the 1. You could just write it as 2 over q, and that's fine also. Lot going on in 13. The first thing I'm probably going to do, I'm going to deal with the outside exponents because they're both, oh, we can just distribute. This is just your quotient, power of a quotient. Let's do that. On the next one, I'm going to do what I'm talking about. All right, so I'm going to give each thing on the inside power to a power. We would multiply. Power to a power, multiply. B to the 0, anything to the 0 is just 1. So let's move things around. I need to move the a to the bottom. And so in doing so, I need to hold that in the bottom with a 1. Then I'm going to move the b to the top and the a to the bottom. Now we're just multiplying fractions. Multiply the numerators. Multiply the denominators. When you multiply bases that are the same, keep the same base. Add the exponents. All right. In 14, we have a single fraction to a negative exponent. So what I'm going to do, I'm going to flip the fraction and make the outside exponent positive. There are truly multiple ways, so if you did this in a different way, see by your final answer if you get to the same thing. So I'm just moving all the top to the bottom and the bottom to the top and making my exponent positive. Then I'm going to raise each base on the inside, each base to the 3rd power. You can either do this step in your head or I'm showing you step by step. 2 to the 3rd, be very careful. 2 times 2 times 2 is 8. Power to a power here, we multiply. 3 to the third, be careful. 3 times 3 times 3. Power to a power, we multiply. And this is going to be p to the negative third, but I don't want the negative, so I'm going to move the whole thing to the top. And there's no bases to combine, so that's my final answer. All right, I'm going to leave the x squared and the y. There's nothing to combine, no negative exponents. This negative exponent means I'm going to switch my inside fraction. I'm going to do the reciprocal, putting y squared on the top, 2x on the bottom. That makes my outside exponent positive. Power to a power, we multiply. Each base here needs its own square. So 2 squared is 4, and x squared. So first, I needed to distribute my exponent through the parentheses. Now I need to combine. Now remember, when we're multiplying, anything from the top can cancel any common factor on the bottom. So this x squared will cancel this x squared. Here if I have a y on the top and a y on the bottom, if I'm dividing bases, I'm going to subtract the exponent. And the 4 is the only thing left in the bottom when I combine my y's. Last slide. Lots of stuff going on here. I'm going to move this a to the bottom. And so it'll be a to the positive 1. I'm going to keep the b squared on the bottom. Then I've got my negative 1 exponent. So I'm going to flip the reciprocal of my fraction. And I don't need to write positive 1 exponent because anything to the first, nothing changes. It just stays the same. Then I need to move this b to the bottom. So then I have to keep my 1 on the top to hold that placeholder. I'm combining my a's. They're being multiplied on the bottom. So I need to add the exponents. Multiplying my b's on the bottom. So I add my exponents. Final answer, all positive exponents, no same bases. All right. So I'm going to move this whole thing to the bottom. And I don't need to make this keep the 1 power because anything to the first stays the same. I'm going to keep my a squared on the bottom. I'm going to move my x squared to the top, making it positive. Now my x squareds cancel when I'm dividing my bases. Really, that'd technically be x to the 0, which is 1 over a times a squared. When I multiply bases, keep the base, add the exponent. All right, 18, let's go ahead. All right, let's go ahead and just move the entire numerator to the bottom. And I don't need the positive 1 once I move it because positive 1 exponent. I'm going to move my denominator to the top. Now I do need to keep that 2 because I got to square everything here. See, if this is just to the positive 1, that just means nothing changes. Then each base, I'm going to square. Power to a power, I'm going to multiply. Q squared. This p is going to stay. This q, I'm going to move to the top to be with the other q. Now that everything is positive, combine your bases. Since I'm dividing the p's, I subtract the exponents. Since I'm multiplying the q's, I add the exponents.